and the stock market shifts. Even, sir.
Hi guys, good afternoon. How are you doing?
Afternoon, sir.
Hi Shaz. I am going to begin in another 4 minutes, so please just get yourself ready, please. And thanks. Trust that you have a good day today. All right, so let's soon start. All right, so let's go. Now, we have been spending some time looking at applications of differentiation, and more recently, applications of integration. And under the application of integration, we have been looking at the trapezoidal rule. Now, I want to give you a question to see how much you have gained from this knowledge. And it's a paper question. Let me just share my screen with you. I'm going to ask you to just use the knowledge, what it is that you've gone through to answer this question. It's really not difficult. I laugh because when I first looked at the question, I was like, what the question is asking? And I did something, and when I came back, I saw what it is that the question was asking me. So to see how well you guys will process what it is being asked of us. And this is May 2019. The sketch below represents the area under a curve y equals x squared plus 2 between x equals 1 and x equals 4. Of the boundaries of the plot of land purchased by ABC Company. The lengths of the particular offset at intervals from the straight line to the curve boundary are shown in the sketch. The field manager of the company would like to know the area of the plot before using it. Calculate the area of the plot of land using the trapezoidal rule. If the direct integration gives the exact answer as 27 square units, find the percentage error in your answer to one above for 20 marks. Can you start with me, please? How is it going? Have you started, guys?
Yes, sir.
Nice.
Yes, sir.
Nice. Good job. Continue. Hurry, please.
By asserting her at this stage because Tuvalu has a candidate, and who knows, maybe Carrick Home, Bishop
How we stay? Any closer yet? I want you to talk to me now, guys, because I want to finish off this
Yes,
so I
sir.
can move in my stuff. Yes, yes, Papa, go ahead.
Sir,
Yo,
you're
sir,
fine,
driving,
man.
sir.
You're fine.
All right, please, hurry up, Papa. Anybody finish it? Hi, how you do? Anybody finish it? No, talk to me.
Yes,
Talk to me.
sir.
All right, I'm sure. Anybody else? Anybody else has completed this stuff? I don't want to just do it saying I want you guys to look at it and give an attempt. Can I give you 2 more minutes, please? Just 2 more minutes, please.
It's just the first part, right?
Yeah, because we talk about the second part afterwards. Yeah, just the first part.
Sir, I'm sending a message. Forgive me, please. But
Okay.
you understand what I want.
You understand what is going on?
I say you understand what I want.
Oh, yeah.
Yes, sir.
I have a question, totally unrelated. Who in here follow dancehall music? There's a question I need to ask you. Anybody?
Yes, sir.
Oh, you follow dancehall musicians?
Yeah. Well, for the most part, sir.
Do me a favor. Give me a quick call now, please. No. On WhatsApp, please. While I wait on the others to finish up the stuff. All right, ready or not, here I come. Yes, AC, walk on. All right, now it says the sketch below represents the area under the curve y equals x squared plus 2. It means that this curve is going to be defined by x squared plus 2. And it occurs between 1 and 4 of the boundaries of a plot of land purchased by ABC company. The lengths of the perpendicular offset at equal intervals of the straight line to the curve boundary are as shown in the sketch. The field manager of the company would like to know the area of the plot of land before using it. Calculate the area of the plot of land using the trapezoidal rule. Now, you see, what I was telling you about, the hypothetical situations about hotel want to buy, a developer wants to buy a plot of land to build a hotel, and if where I live it becomes a prime plot of land, and the big man may say, boy, say you could have built one nice little something out of this. The man can actually approach me and say, here the plan, Papa. Say, I'm going to buy a plot of land from you, You have a 3-bedroom house on this plot of land. I'm going to make one for you. I'm going to give you a 6-bedroom, or I'm going to give you 2-bedroom, a 2-3-bedroom house. And this has happened before. I've heard, somebody that is known to me personally had owned a property that where the property was located would have blocked the entrance to, a developer bought a piece of land, but this person that owned the property, they wanted the entrance of this plot of land to be on a particular avenue. So they needed to demolish the residence of this individual. This person actually taught me in high school. No, taught me in school, one of the schools that I went to. And I was told that the person sold the developer. And what the developer did was to make a house for the individual in an upper scale community so that they could build this plot of land, this apartment. And subsequently, a co-worker of mine purchased a house over that place. And I had cause to pick up that person one day, and I had a look at the plot of land or the development. And it is a monstrosity of a building. So I'm saying this to say to you that what I'm telling you happens in real life. So it's not a make-up situation, real stuff. So ABC company here, wants to get an idea of the area. And remember, in order to increase the square footage, you're going to build vertically. So you may have and this is why, and this is how the people in Portmore do it. Oh boy, I don't know what I'm going to do with QC. I wish I were one of those people, because if one of those developers QC come to me and say, here the plan, bossy, you see your plot of land, I want it, because I want to do X, Y, Z. Me and lay it up on the table to him. I'm going to say, guess what? Not only that you are going to relocate me to a different area. You see, when your development done, I want one of the units them. Come on, that is going to be my investment. So, me will give you my plot of land where me live, so you can build and expand your construction. You're going to buy me somewhere, so me can relocate and put me and my family and my friends them. But in addition to that, one of the units, I want a 1-bedroom unit. If a 2-bedroom and 3-bedroom unit you build, I want one of the 3-bedroom unit. Because guess what? Me going to get an extra house out of you. Me going to do it. Me no lie. Real talk. And I'm telling the students, it's what I'm telling you about. Let me ask you a question. How many of you live in areas where you see them put up thing on the light post to say, we buy houses cash? Anybody ever see that yet?
Yes, sir.
No, sir. Rich people here.
Charlie, you and QC, they're gonna move, you know, but nobody don't have to be rich people. Developers want to. You see, when you're going to, some of them, like, let me call one of those places. It's like in the Meadowbrook, Havendale, Hagley Park, Richmond Park areas where
Off Mullines Road as well.
yeah,
Any
man,
area that has large plots of land whereby they can.
Absolutely. Yes.
Yeah, anywhere that have large plots of land that can do all 3-story, 9-bedroom,
Yes.
9 separate bedroom apartment buildings, then you buy that.
Yes, Andrew. I saw you in a real life. The man them they come and let me tell you, and them have money for tree, you know. So them tell us, I'm gonna buy a house cat.
Sir, upscale, what do you call it? Tenement yard.
It's because I don't want to offend anybody. I agree with you. But because I don't want to offend anybody, there is a big tenement yard on Constant Spring Road near Queens. I don't know if you can get the idea. Yeah?
Walklands.
Me say, me never call it. And I don't want nobody to tell me, oh, me come to class and tell us them live in a one rare area. But let me tell you, when I was studying on campus, one of my friends who come from country, parents bought an apartment there. So he and his brother lived in the apartment while they were going to school in Kingston. He was at UWE, his brother was at UTech. Nice place. Place I'm gonna go every Friday before after school done. We just go hang out and then we leave and go to church and nice place. The youth gone foreign, and his mother, he came back and his parents were there and them said, no, Sean, come in, man, I'll go to the place. Brethren, no story. Me said to them, say, you know, sell it. Them said, boy, it's their go-to place in them need country. Them just come and stop in at Kingston and can sleep before them go back out. The man, them play their music and you can't tell a man to turn it down because the original owners, them move out and rent out the place. And these tenants there just, me not living over. If them give me a house over there free of cost, the apartments that is, the townhouses are different. But when you go on the high rise, you give me a house up there for free of cost and groceries every week. I'm gonna tell them no want it. It's rough, man, rough. But let us use Oakland as an example. So Oakland has a particular plot of land. I'm not talking about the townhouse side, I'm not talking about the apartment. They increase their square footage by building vertically. And this is how industries operate. So I really want, when you're doing these questions, you have an idea of how it works in real life. I don't want you just to do the question because of it. I want you to be able to appreciate it. All right. Now, having explained that, the man them say we need to calculate the area of this plot of land. We know trapezoidal. Did anybody calculate the width of the interval?
Yes, sir.
Oh, that's it. The delta something there.
Delta X, yeah. What you got?
Yes, sir. 3/6, or basically half.
3/6, which is a half. Okay, great. So your interval is a half. All right. What did you do next?
Found the ordinal, sir.
Mm-hmm. How many ordinals?
7, sir.
Mm-hmm. Did anybody get that? 7 ordinals?
Yes, sir.
How do you know that there are 7 ordinals?
Yes,
Sir,
sir.
it depends on the graph, sir.
Oh, it depends on the graph. Mm-hmm. So how many trapezoids then?
1 less, so that'll be 6.
Very nice. Very nice. Very nice. I want you guys to talk to me like the way you're talking to me. Very nice. I know some of you are at work and some of you just reach in and are in here some food, but very nice. All right. Now, my first ordinal will be what?
1.
Which is my lower bound. And my last ordinal will be
4.
4, my upper bound. All right. So when I substitute 1 into the function, what will I get?
3. 3, sir.
When I substitute, I get 3. Okay. What is my next ordinal?
1.5.
I mean, I substitute that into the function. What do I get?
4.5.
Really?
4.25.
4.25 will be correct. What's my third ordinal?
2.
Mm-hmm. When I substitute 2 into the function, what do I get?
6, sir.
Nice. Are you seeing what I'm seeing? No, you're not seeing it yet. Okay. What will be the next answer when I substitute
I
out
think
of
it's going
ordinal?
up by.
Sir, the answer them actually on the graph. It seems.
Ah, yes, I.
Right.
So and everybody recognize that the answer that the things are actually on the graph itself.
Yes, sir.
Mm. So when I started doing the question, I was like, okay. I looked at the graph and I said, all right, so it's 1 to 4, and I'm going to have 7 ordinals. Okay, let me go ahead and do my delta x. And as I calculated, I'm recognizing that my first value is 3. I look at the graph and say, I'm seeing some 3. And I calculate again and I get 4.25. I said, but hold on, what go on? I said, all right, let me see if I get 6 and all. And when I calculate, I then recognize this is what was included on the graph. So my fourth ordinal, of course, will give me 18. So technically, what I could have done is to go ahead and say 3 plus 2 times 4.25 plus 2 times 6 plus 2 times 8.25 plus 2 times 11 plus 2 times 14.25 plus 18 multiplied by delta x over 2. Remember, it's my first and my last terms that are not affected by the double base. So I would have gotten all of that. And then I would have ended up with 217 over 2 times my 1/4, and I'd have gotten 27.125 units squared as my answer. Did everybody get that?
Yes, sir.
Yes, sir.
What's up with the others though?
Sir, never get to finish.
Okay. All right. Yeah, so I'm going to get 27.125. For those of you who didn't get it, I want you to look at it. I'm getting 33.4 for my. I was just about to call upon you, Nico, to say that I did not see you last class. And I say, you know what? Maybe I'm mistaken. But based on your comment, I kind of feel say it's true. All right. 4.25 is the same thing as 17/4. My 6 corresponds to what it is that they are saying. And my 33/4 is going to be 8.4832, 8.25, which is here, right? So I would have gone ahead because they can give you this exact question, you know. Come whenever you have your final exam, they can give you this exact question. We don't know what you can do this time around. Take up the answers right here, the 3 to 4.25 support and so on. And including the question that it has 7 ordinals. Or they may not say 7 ordinals, they may just say to you that it has 6 trapezoids. Which is the same question, but it's just that they take off some information and put on something else to it. All right, hold on. Hold on. All right, so let us continue. All right, look at it for me, please. I'll come to you, Nico. So it says if the direct integration gives the exact answer as 27 square units, we need to find the error. While Onika looks at this, I want you all to integrate it to see if you really get 27 units for the question. Go ahead and look at it for me, please, and do the integration rather. Giving Onika a bit of time to just go through this workout and engaging you in the process for just 2 more minutes, please, and thanks. And those who didn't finish this question, just go and finish it off for me, please. There's a point I want to do. What I'm trying to do, if you don't figure out yet, is to introduce you know how to calculate the error, because you know how to do the error. So I'm introducing that to you. So 2 more minutes and then I'm come at you. Look at it for me, please, Nico. Wint, you weren't your last class neither, because I was calling upon you and you didn't answer. So you need to look at it, please. Are you finished with the actual integration?
Sir, can you just explain the right after we have this tell the width of the chop right there, sir. Can you just explain it there? That's
All right,
right.
so all right, no problem, my pleasure. So what happened now is that in order to tell me to find the width of the trapezoid, because remember the trapezoid must be equidistant, equal distant. So that's why we use the formula B minus A over N, and N is the number of trapezoids. See here, B minus A, and B is the upper limit, A is the lower limit. So it's B minus A over the number of trapezoids. Now, one of the things that we were riveting in the class last week is that the ordinals is one more than the number of trapezoids. So you have 7 ordinals, it means that you have 6 trapezoids, all right? So it is going to be divided by the number of trapezoids. So it's going to be 4 minus 1 divided by 6. 6 is the number of trapezoids, but sir, it has 7 ordinals, yeah. 7 ordinals, 6 trapezoids. Ordinals is one more than the number of trapezoids, or the number of trapezoids is going to be one less than the number of ordinals, whichever way you want to say. So 4 minus 1 is 3 over 6, which is going to be equal to 1/2. But when you look at the formula says delta x over 2. So this 1/2 now is going to be divided by 2. So I was just showing you how it is that we do the division, because 1/2 multiplied by 1/2 is really, or I could say 1/2 divided by 1/2 is 1/4, right? So that's what I was showing you right here. This delta x over 2 is 1/2 divided by 2. When I divide 2 fractions by, when I divide 2 fractions, I multiply, invert. So therefore this 1/2 is going to be the first one. And then this divided by 2 over 1, I'm going to invert it. So we're going to call it 1 over 2 and multiply. See here, 1 over 2 and then multiply. So we can get delta x over 2 to be equals to, see right here, so 1/2 divided by 2 is going to result in 1/2 times 1/2 because I'm inverting and multiplying. So I can get 1/4. And 1/4 now, if you jump down here, so 1/4 is going to be what I'm going to put in front of my sum in order to fully evaluate my approximated area. And then I'll just go through the rest of the question with you. And then what we did now, I just recall what the original question is, since I didn't want to be scrolling up and down, which is x squared plus 2. I am not actually doing the evaluation of the limit. What I'm doing is going to be substituting my ordinals. Remember, 7 of them are supposed to have 1, 2, 3, 4, 5, 6, 7. So each ordinal will be substituted into the question, the original function, evaluated, and then I'm going to work it out. But before I work it out, there's something special that you must know. Something special that you must know. So f of 1 is our first one here. It's going to be 1 squared plus 2, which is 3. F of 3/2, which is my second ordinal, is going to be 3/2 squared plus 2, which gives me 17/4. My third ordinal is going to be 2. So f of 2 is going to be 2 squared plus 2. So anywhere in my f of x, I see x, I'm substituting all my ordinals. I'm going to end up with 6. 2 squares is 4. 4 plus 2 is 6. My third ordinal is going to be 5/2. My fourth ordinal, sorry, is going to be 5/2. So it's going to be 5/2 squared plus 2 is 33/4. Then the next is going to be 7/2. No lie, 3. And then 3 squares is 9 plus 2 is 11. Then I'm going to have 7/2 squared plus 2 is going to be 49/4 plus 2 is going to be 57/4. And the final one is going to be 4. So it's 4 squared plus 2 equals 18. So all I'm doing is just substituting these values into the sum. Simple algebra, simple 1, 2, 3. When I'm doing my approximation, I am not actually calculating the area. I'm only approximating. I'm not calculating the area. I'm only approximating. I asked you, yes, to do the integral after because I'm teaching you something and I'm getting somewhere. All right. Let's go. So what we're doing next now, there is something special, Nika and Shanali, because I don't think we're here, with the formulation. My first term, which is my lower limit, and my last term, which is my upper limit, are the only two in the formula that will not be multiplied by 2. Every other term, see here, has a multiple of 2 to it. Why, sir? Because this one is going to share the base with this and this. So it has 2 bases. So each middle term, and all of these are referred to as middle terms, will be able to share 2 bases. Just the end one will be sharing just 1 base. All right? So I say this to say to you, I'm substituting into the formula. So the first term is not going to be affected. So it's just 3. This one is going to be 2 times 17 fourths, 2 times 6, 2 times 33/4, 2 times 11, 2 times 57/4. But the 18 is going to be just plus 18. So the first term and the last term are the only 2 that are not affected by the multiple there. And of course, I showed you how to calculate this 1/4 just now. And when I multiply these 2, I'm going to get 217/8, which gives me 27.125. And that's the end of the first piece of the question. That's an approximated value. My question now is, did you work the actual integration for me? If so, what did you get?
Sir, I got 15.
What?
27 units squared.
It's supposed to be 27 unit squares. Look at it, Sash. Do you have x cubed over 2x? I mean, sorry, x cubed plus 2x, Sash?
Yeah.
X cubed over 3 plus 2x?
For the upper limit, I put 4 squared plus 2.
No. You need to integrate it on in bunches.
Oh, Jesus. I did the wrong thing. All right, sir.
Yeah, man. So I was asking for the actual integration. So let me tell you why I asked for the actual integration. In this question, they didn't ask for it. They only told you what the actual integration yielded. And then they're asking you now to calculate the percentage error. You remember last time we did a question in class and Yannick was saying, boy, sir, if them people at the hotel people, you tell them, say them are going to get 7,000 square feet. And in actuality, what them get is only, yeah. And in actuality, what them only get is 3,000 something when I did the actual calculation. How would you explain that, sir? Remember, it's an approximation, you know. So all of what it is that we're going to be doing is to say to the guys, this is an approximation. Let me give you an example. While Sash works out that one, let me give you an example. So it's when you go to the market and you buy a whole pumpkin or a whole watermelon. When I say a whole, you know, it means them not cut it. Pretty much you buy puss in a bag. Do you pay more or less than what they're selling it for as if they were to cut it? Per pound. Talk to me now.
You pay less, sir.
You are going to pay less. No, you're going to pay less. Very good. You are going to pay less because they are not the ones cutting it. So if when you pay less, so if I'm buying a whole of watermelon, but me answer you how much a pound, him say $200 a pound. Me say if I buy a whole of watermelon, how much you get it for? You can get for $150 a pound. I say, but wait. If when we look on the watermelon, then we cut, and if we cut them, the one that we already cut, they said no man, them they look good. Me can chance it and buy a whole of watermelon, but I run the risk when I carry it home that it's not good. And if he were to cut it there, so for me business, because me don't buy it already. Same thing with the pumpkin. So the pumpkin may be $50 a pound, but if I'm buying a whole of pumpkin, I may get it for $30 or $40 a pound if I buy the whole of the whole of pumpkin, right? So you're going to actually pay less. It is what it is right here. So when you're looking at the question, and then I can calculate the percentage difference. I can calculate the percentage difference. So that's exactly what it is that you're doing the question. We don't need to calculate our error in doing the stuff. What is the percentage difference? Right? So let us see if we can do that. Let us see if we can do that. So what we're saying here is that the actual is 27, or approximated value was 27.125 squared units. So if I say 27.125 squared units minus 27 over my actual, which is 27, times 100% is going to give it 0.46%. So that's what I'm estimating to be my percentage error. So in this case, my percentage error is not even 1% because I came out to be very close. So I told you the situation of the watermelon and the pumpkin, based on the question that you need asked. Sometimes your error may come out to be 0 because you get the actual stuff. Remember, the more trapezoids you use in the question is the closer you become, you get to the answer, the actual answer. So in this case, I am really, really, really very close, because if you look at it to one decimal place, I'll be 0.5%. I'll be 0.5%, which is, in real life, it is almost negligible. In real life, almost negligible. Look at that. Look at that here, man. Almost negligible. A man can get $1 million, and you say, blow $1 million, but to the man, it's neither here nor there. Because if the man I get a pull down $1 billion, and the man get $1 million out of that $1 billion, he's not feeling it. He ain't feeling a thing. All right? But to somebody else, it's a whole heap of money. All right? So that's my method 1, where I'm calculating the stuff. Now look at my method 2. Now, the trapezoidal rule, error bound, the trapezoidal rule, error bound, E subscript trap means error for the trapezium, error for trapezium. You're looking at the absolute value. What is the absolute value, sir? Absolute value means that you will always get a positive value. You'll always get a positive value. You'll always get a positive value. All right? So your error for the trapezoidal rule, the absolute value is going to be less than k b minus a cubed over 12n squared. B minus a cubed over 12n squared. Now, the second derivative of the function should be less than or equal to that value k. The second derivative of the function should be less than or equal to the value k. All right? But sir, you tell me say there's another formula right here, so yes. E subscript trap, the absolute value of your error for the trapezoidal is going to be equal to K times B minus A all cubed over 12n squared. Watch me. B minus A, we know that. It's an upper limit minus the lower limit. The upper limit is 4. The lower limit is 1. 4 minus 1 is 3. We know what n is. N is the number of trapezoids. N is 6. We're getting K to be equal to 2. K equal 2, sir? We get K equal to, watch me. The first differential, remember this is a second differential, you know. This is a second differential. Let me recall something. Copy. Boy, I don't know if I don't have this copy button on this system. Oh Lord. Hold on, guys. My computer gone again. Okay, so I just got lost. Where am I? Right here. Right, so I'm going to recall that. Now my f dash of x, which is my first derivative is going to be 2x. Can you agree with that?
Yes, sir.
And my second derivative, differentiating 2x one more time, I'm going to get 2. So that's what the k is. Oh, all right. So watch me now. So if k is 2, it's going to be 2. B minus A is 3, so it's 2 times 3 cubes over 12 times 6 squares. 3 cubes is 27. 27 times 2 is 54. 6 squares is 36 times 12 is 432. So I'm going to get 1/8. When I times that by 100, I'm going to get 12.5. Right? No. So somebody may look at it and say, boy, sir, I would prefer the first one. But really and truly, the error of the trapezoidal is by applying this formulation right there. Let me go back to your syllabus and check on something course outline. MATH4702. And I'm going to check with you. But the error trapezium is not difficult. It's just k times b minus a all cubed over 12 times n squared. And you know, in the question, you'd have already known what b minus a is, you know what n is. It's just for you now to differentiate the function, you know, to find the second derivative. And then you're good to go. I'm just waiting for this thing to come up. All right, let me just share this with you. So we look at it together. That's the mean value theorem. And this is what it is that we're looking at in terms of the trapezoidal. 2 times this thing I type properly, you know. This is 1/2 h. This is y subscript 0. 2 times y subscript 1. 2 times y subscript 2. All the way down. But h is going to be b minus a over n. The difference over the number of trapezoids. All right. Determine whether the actual error is overestimated or underestimated by calculating the percentage involved. All right. So if you see what is happening here, so we need to calculate the percentage error involved. And they didn't give us the formulation. percentage error in, the percentage error involved. Right, so we're going to be using the E-trap. It's a more accurate calculation. Yes, it's a more accurate calculation, right? So it comes back to the point that was Yannick referenced. Then, sir, what if the man them did do the calculation and get that? Where I tell the man them say, this E-trap is a more accurate form of giving you the percentage error compared to the 0.46 that we got before. All right, any questions? I gave you that to do before. X squared plus 1. Was that what I just did? All right. I have one more for you.
One question.
Go ahead,
Sir,
man.
sir, you just said K is the second derivative?
Yes, only one choice.
Okay.
So follow up to that. If it is that the you can break it down past second derivative, that should be so, right?
If it is that you can what?
If you can break down past the second derivative, that you should go ahead and do that.
Yeah, but we're going to be using the second derivative though. I know what it is that you're asking. You're asking me. What it is that you're asking me is that, sir, when you did this question a while ago and you differentiated it, we could only go to the second derivative. What if we could go beyond the second derivative? That's what you're asking, right, Sash?
Right, right.
Good. All right. So there are different types of approximation. There are different types of approximation using your applications to integration. When they're going to give you the questions on the trapezoidal, however, again, it comes back to the question that was asked, sir, when these exam questions are being prepared, demand them do the question before because we not trust your question, enough, sir. Yes, because what is happening is that I went ahead and did some preparation for you using something that is called Simpson's. But when I look back at the syllabus, Simpson's rule is not on your syllabus. Now, Simpson's rule is another form of approximation using using integration, right? Don't internalize this a whole lot, right? There are some conditionalities for this one, and you can see me highlighted. N has to be even. So the number of trapezoids in this case must be even. When you do the trapezoidal, you can have odd numbers. You can have 5 trapezoids with 6 ordinals. You can have 7 trapezoids with 8 ordinals. But in this case, when you're using Simpsons, it has to be equal, right? So it says another error approximating tool is Simpson's rule. Geometrically, it creates tiny parabolas to wrap around a function we are approximating. The formula is similar to the trapezoidal rule with a slight difference. You can only use even numbers in the subintervals. What happens? This time here, because you're using tiny parabolas, you will have alternation of the numbers. So if the first one and the last one, they have nothing. As I said before, don't internalize it. I'm just pointing out some stuff. Then the first term afterwards will have 4, then 2, then 4, then 2, then 4, then 2, then 4, then 2. So they alternate like that. For the trapezoidal, we have delta x over 2. The one you have delta x over 3. What's the point I'm making? So you will go ahead. I can only use even numbers. My trapezoid have to be even numbers. So once it is that I'm using Simpson's rule, I can't say n equals 5 because it won't work. So I'm saying this to say to you, when I get my stuff, I can use whichever of the approximation such that I believe will best suit my question. If you get what I'm saying. All right. So they will not give you a question. They will not give you a question that is going to be technically out of your scope. You know, like, sir, can I give you a question? I said, you know what? There is no solution right here. Like I gave you last class. Oh, stop. Don't go no further. This is integration by parts. It's not that the question can't work because I finished working the question and I was able to tell you what the answer is. But integration by parts is not on your syllabus. Just like why I'm not seeing Simpson's rule on your syllabus, I went ahead and prepared something in vain, but I say, you know what? I'm not even going to delete it. I'm going to make it stay there. All right. So I'm saying to you, good question, but you don't have to worry about it. All right. I'm going to project this. We don't have much time. I'm going to project this one. Oh, Lord. I have two that I wanted to give it. All right. I can send that off to you. Do that one quickly for me, please. I'm giving you 5 minutes to do that one for me. Approximate the area beneath by equals x squared plus 1.
Sir.
Yeah, man, you're calling me a long time?
Sir, this question here, didn't you already give us this?
I gave you that one already?
Yes, sir.
Oh, yeah, Jason. Forgive the high. Seen a moment. Forgive me. 1.1. Let me see if the answer is 1.1. No, 12.18. Yes, that's what we gave last time. All right. Did I give you the e raised to the x squared plus 1 before?
Let me check. Yes, sir. Yes, sir.
Well, we are going. Oh, yes, that's the one we did in class. We're going, we're gonna move hard. All right. We're moving hard. Then I gave it that one. All right, very nice. All right, let us therefore jump. Where's my phone? Let us therefore jump into the. Let us jump into the past papers. Sash sent some last time in class.
Sir, Charlie?
Well, I don't know. Somebody sent something in the thing. I'll check and tell you who. Yeah, no, your name Kimberly.
Yes, sir.
Yeah, you know, send some past people. Oh, cockroach, you know, send some and a past people. My fully, G's and P's. You know, I thought they were past papers. And that's why I said thanks to the upload. You remember me thank you? Oh, Jesus.
Sir, me spend it long time.
When I looked at it, anyway, Yannick, you have a past paper there? Anybody has a past paper with them? Anybody, please.
I have to go through channels to get them.
Oh man. Hey, you want to hear me talk about thanks for the upload? Because I'm saying to myself, yes, we have past papers now. All right. We have 5 minutes left. So I don't want to go and generate another question at this point. I don't want to generate another question at this point, but just to say that, yeah, not only that, this is the end of the trapezoidal. All being well, Thursday I'll start looking at calculating the volume of rotation, rotating things about the x-axis and about the y-axis. So let me just see if I can use a minute to get an idea as to where your spatial awareness is. If I have this curve, x squared plus 2, right here, so, and I'm rotating this curve about the y-axis, what shape do you think it's going to get? No, let me say it again. So I'm holding the curve, and I'm rotating it about the y-axis. The y-axis is this axis here, and I'm rotating it about the y-axis. Tell me what shape you think is going to be formed. Just visualize it. What shape you think is going to be formed? I have this, and I'm rotating it about the y-axis this way and coming back. I'm rotating it 360 about the y-axis. What shape do you think is going to be formed? Many of you have it at home too. Nobody? Anybody? Somebody? Hello, somebody just unmute and talk to me, please. We have 4 minutes, please.
I don't know if I make out of that.
Anybody else has an idea?
Or is a circle?
Okay. So you'll have a circular top, yes, and a circular bottom. But give me the general shape. What do you think is going to be formed?
That's the question.
All right. Let me spotlight it and show you. I really hope that you guys are not going to be challenged spatially, because the next topic that I'm going to move into will cause you to start seeing things. Look, so I have this curve, and I want to calculate the volume when this curve is rotated 360 degrees about the y-axis. This is my y-axis, and I'm rotating it. So all of this curve, I'm rotating it about 360 degrees. 360 degrees is a complete revolution. What shape do you think is going to be formed when I rotate this curve 360 to the y-axis?
So a circle that you eventually get, I think, are oval looking something.
Relate that to something that I know all of you have in your house. It's going to look like a
What?
Okay. Anything? Anybody else?
Frying pan.
Frying pan. Okay. You can warm up.
Sir.
Huh?
Egg, a clock.
A clock. Okay. Interesting. Anything else? Anybody else?
There's the egg.
It like an egg. If you never related to foods, my name change.
How old is your Anita?
No sauce. No sash.
Yes, sir. I told she don't play with designer.
Me know that man. Around with her and her food, man. She's serious. What do you think? Talk to me now. Lexton, come talk to teacher. What do you think? Anjo, what do you think it is?
Sir, somebody did say it already. Oh, clock.
It look like a clock. All right. What if I say to you that it will look like a fruit bowl?
Yeah, possible, sir. Based off of
Yeah,
the curve.
yeah. So the top part of the fruit bowl is going to be wider than the bottom piece down. But when you look down in the fruit bowl, you're going to see a circular base, but you'll also see a circular top. So you can see that you'll have circles in it of different diameters. So when you say
Everybody
circular
have
stuff,
fruit bowl, sir.
everybody have one fruit bowl. You know, I'm a soup bowl. Sash, for somebody who love food, you must have one soup bowl, Sash.
Sir, what's no shape like that, sir?
I'm gonna ask you, and Sash, when you go buy your banana and your apple and your strawberries and your grape, you take out a soup bowl and put in it and put on your table or put on your countertop because you want it to look pretty. So if you have a wooden one or one glass one soup something, and you call it your fruit bowl, or the same something. Yeah, man. So I get an idea now. Go ahead.
Right now, the same shape, sir. Me a picture I have soup bowl, sir. But it's not have a shape, sir. Some of them square now.
No, we're not talking about the square one, honey. We know some of them square. We're not talking about the square one. We're talking about the circular one. All right, let me ask you one more question quickly before we go. So I have this piece right here, so. So we have this piece right here, so. When I rotate it about the x-axis, what shape do you think is going to be formed? Let me see, and name it the shape.
Go again, sir.
When I rotate this about the x-axis, the same shape about the x-axis. When I rotate this shape about the x-axis, what shape do you think is going to be formed? When it rotates about this axis here, so what shape do you think is going to look like?
Semicircle.
And quite a number of us eat it too.
Banana.
Or a banana.
No.
Or a pear.
No. Well.
Sir, maybe a trapezium.
No. You eat trapezium?
Sir, a melon.
No. Sir. No. Oh my Lord. Lord, am I going to have problems teaching this topic? Look at this and tell me. Listen, I'll give you one more minute.
Sir,
look at this.
The art, sir. That's why.
Yeah, but we never do art and craft neither. But look at this. Look at this piece here. This is the thing. And I'm rotating about this axis. Not this axis here, no. I'm rotating about the x-axis now. What shape do you think is going to be formed? Somebody just hazard a guess, please. Somebody just guess something, please.
Patty.
What? Who is it?
Patty, sir.
Oh my goodness gracious. No, clearly it is a wrong time of day I'm having class and everybody is hungry.
We're hungry now. My sister just gonna ask me about dinner.
Yeah, man. All right. So if you look at it, if you have a cone, an ice cream cone, and you cut the cone, you know, you have some ice cream cone that is flat, that can actually stand up. Not the one that Devon Host sell. They have some other ones in boxes that is flat, that can actually stand up. If you were to cut this in half, does this look like half of a cone?
Yes, sir.
Yes, man. So guess what? When I rotate all of this here now, the shape that is going to be formed is going to be a cone. The shape that is going to be formed is going to be a cone.
Sir, you know, the entire sir, I'm thinking about that in the sir, but you say all the way around.
Yes,
the
it's all
entire thing you're talking about, like from 1 to 4 up to the top part of the thing.
everything I rotate,
Not,
everything.
sir, never talk what you mean, sir.
But that's what I said. I'm rotating this shape about the x-axis. So the whole shape is being rotated about the x-axis. So I'm going to end up. So if you look at it, watch my thing here. If you look at it, it's going to come out so. Then it's going to come down so. And then I'm going to have this piece here from up here so to down here so. And then this piece can curve and come back up here so. So I'm going to have what a cone. It looks like a cone.
So you must talk like it's reflecting on the x-axis, sir.
It's not really a reflection, it's more of a rotation. But all right, so I know where I'm going to have a difficulty. When some years ago I taught this course, and when I was teaching it, the students couldn't get it, and one student in the class had something called SketchUp. I mean, I had a copy of SketchUp and I don't know where it's gone, honestly, because if I had my SketchUp, I could then put this in my SketchUp and rotate it so it is that you can have a look at it. So those of you who are very good with exploring these drawing tools, I'm going to be calling upon you. I'm going to see if I can find me a free version of SketchUp, even for 30 days, that I can use with you so we can concretize this topic. And then after this, now we're onto differential equations, then multivariable functions, and then we're done with the course. Have a wonderful rest of the night.
Good night, sir.
Bless up. Cool.